How about you?
Doing good, doing good. So we're been streaming 8 hours now. You're pretty much we're,
It's
we're
kind of
already
crazy,
four people.
dude.
Yeah, you want to give a quick introduction on yourself?
Yeah, sure. I guess I did this about last month ago. Like I did a mock with you, but
Oh,
I'm a
really?
student.
Damn.
Yeah. So
Oh yeah, I
I'm a
remember
more
you now.
the SpaceX kid.
Oh yeah, yeah, yeah.
Yeah. So yeah, no, I'm a more CS math student, recent grad, and I pivoted from pre med to CS and math.
Hmm.
Yeah, that's kind of it. I interned at two places, two tech places, John Deere, and then recently Samsara. Yeah.
Yeah. Oh, this is cool. Um, and you said that you wanted to. How was the SpaceX interview or whatever? You end up doing that?
Dude, yeah, they flew me out. It was on site. I can't disclose
Yeah,
like
the NDA.
specifics.
Yeah,
But yeah, because of the NDA. But I mean, what I can say, it was hard,
yeah,
and that's kind of what it's like online too,
yeah,
or what most people say online. But yeah, no,
yeah,
it was a hard on site, and it was kind of long.
yeah.
But yeah, it was fun though. It was fun. They
Like
asked
how
me
would
some.
how would you prepare for it again? Or would you study more data structures and algorithms, or would you study other things?
Dude, I think the only way you pass SpaceX is if you just do a lot of projects and know a lot of technologies in depth. Like it's not even like leak code.
I
I
see.
feel like the leak code is like the DSA stuff they test you on is not too difficult.
Mm-hmm.
So if you just paid attention for like one semester in your like course, you'd be fine. But like they asked me a lot of questions on like technologies and stuff like
Yeah,
that.
I
No,
see.
no, I
Yeah,
wasn't prepared for that.
cool. So for this one, you want to do a system design interview?
Yeah,
Nice,
yeah.
finally something different. This is gonna be fun because I was spamming the leak code, and this is gonna be somebody different than Alpha doing the system design. I'm gonna do another stream where I just get people doing straight system design because I feel like that's where people have the most gaps, and we can learn.
Yeah,
We can actually have the most juicy conversations.
yeah. uh, how will
I sent it to you
sorry, I
in
didn't.
the Google Meets.
Oh, okay. Sorry, I wasn't looking at the chat. Cool. Thank you. Appreciate it.
Um, So just tell me up front, like what system design questions have you already solved?
Dude, I've looked at the URL shortener one. That's it.
Okay, let's see. Okay, so let me think of one. Okay, let's just go with a classic one that a lot of people should start off with. But let me think. Let's do. Okay, zoom in. Let's design Yelp.
Okay. Oh, all right.
So I'll just leave this out there and drive the conversation.
Okay. Let me okay, so it's in the drawing too, right? Okay. Um where sorry, I'm not familiar with the okay. I think I can kind of typing. Okay, okay, I can type here. Sorry, I wasn't familiar with the
Oh yeah, I
drawing.
don't see you typing.
Can you see the text icon?
Yeah, type all the way up here.
Oh, I got you. I got you. Oh, okay. I didn't realize I could zoom out and stuff. Okay, okay, cool, cool, cool. Okay, nice. All right. So I guess like from what I've seen, um, at least of how other people recommend to approach the system design is they want you to first talk about like some of the functional requirements. So yeah, and I'm also not too familiar with Yelp either.
Hmm.
So it'd definitely be nice for me to just like iron out some of the
Yeah,
requirements. Is Yelp the food rating, the like restaurant
yeah.
rating thing?
Let's
Okay,
let,
okay.
let's just talk about it in this case of you just want to find restaurants. It allows you to discover restaurants. It doesn't need to be. We don't need to add the ratings like 4 or 5 star. But
Okay.
pretend we want to look for restaurants around me or sushi or whatever. It just shows me local businesses. It's basically a business directory.
Okay. Uh, Okay, cool. So yeah, okay. So the first thing is that I guess like from a user perspective, you want to discover restaurants, right? So we need, I guess, some way to like catalog, like store restaurants, maybe restaurants nearby, filter stuff like that. But like from like a client perspective, client slash user perspective, you want to be able to like filter plus find like near nearby, not even nearby, just like places in general, and then the filtering could take part of the places. Aside from that, so that's like the main thing. Aside from that, maybe there's also like a business perspective too. So like maybe like businesses should be able to add their place to website.
Mm-hmm.
So like that makes sense to me. And then also like the verification too. We don't want a lot of like random verification, like uh verify the business exists plus is real. Like I don't know, is real. Like we don't want a lot of like spam and users. And maybe we could talk about like if like this is still like is this still an assumption? Um, I guess in this problem specifically, would you want me to kind of address that, or would you say that that's like a nice thing to talk about in the
It
future?
might be a nice to have. Could you just quickly iron out what we mean by this? Like, let's be more specific here. So,
Oh, the client user perspective. Okay. So yeah. So I guess like a user. So they should be able to like log in to website and kind of how I imagine this is like on the homepage. There's some sort of like feed of um, like places, like restaurants, for example. And then from there, I can imagine like the user like can like continue to filter, right? Based on search, uh, like proximity, and then like type of food. That's kind of what I'm thinking right now. Is there
the users
I
can
guess is there like
filter
a
based on search. Users can filter based on proximity. Okay, yeah. Essentially, just users have different ways of filtering
right? Yeah, yeah, yeah.
or filtering down the data. They have different ways of search. Okay.
Mhm.
Yeah, that makes sense.
And then I guess we don't have ratings, so that's out of the picture. Trying to think of anything else that user. I mean,
We could
like
talk
I
about it
guess
if we
yeah.
get there, but yeah, I think for functional, that's good.
Okay,
Let's move
and
on to the
then
next one.
yeah, and then the non-functional requirements.
Just write it down here. It might be easier. Down here.
Oh yeah,
Sorry. Thank you. Just for
uh yeah. There we go. Bang. Is that good?
yeah, that's good.
Non-functional requirements. I guess yeah, the rating, the nice to have. And then we think like in terms of like latency, do we need like super low latency stuff? I don't think so. Um, it would be nice, but like
Well, first
low.
off, what are non-functional requirements?
Yeah, so I'm thinking these are like the functions that wait, sorry, I had to close my door.
No problem.
These are the okay, so these are the things that would be nice for a user to have and for our app to have, but are not like directly like impertinent to the actual like everyday scenarios
Well,
of
that's the nice to have here, right? Isn't it what we're talking about? Like,
I guess like
how would you explain
um
non-functional?
yeah, I guess like the one example I'm thinking of is like in the URL shortener, like the non-functional would be like extremely low latency, because there's a redirect happening and you kind of want to make it like as similar as possible.
Yeah.
So, um,
Why
man,
is that
I guess
important?
like in the URL shortener,
Or yeah.
that's because like it's I guess like you want to make it as close to like navigating to the original URL as possible, even though you have the shortened URL. So you don't want your user to like type in this shortened URL and then take forever to navigate. Instead,
Mm-hmm.
they could have just like
Yeah. Like
done the
for
real
from a
URL.
user, it's not us. Like how I describe is functional requirements are what does your system actually have to do, right? These are the actual functions that your system has, which is you can view a list of restaurants. You can or business could also add to those restaurants. You can filter, etc. Those are actual things that the system needs to do, right? And then
Yeah.
non-functional is more about behaviors or the user
Oh.
experience kind of thing. Um, it's sort of like the illities they say of like is it scalable? Is it low latency? Is it reliable? Like reliability, all those different things. This is how does your system behave?
Hmm. Okay. Yeah. Yeah.
So
Okay. That makes sense. Yeah, that makes sense. Okay, that's definitely a good clarification.
mm,
Okay, so I guess for non-functional requirements, like how it'll behave, um, maybe like I guess in terms of like I guess the scale, I can imagine like there might be a ton of restaurants or like places
mm,
that might like add themselves.
yeah.
So dealing with like scaling up from zero to like
Mm.
all the restaurants in the area, for example.
Okay, let's talk
That
about latency. Why would it be important to have low latency?
Yeah, yeah. Yeah. So, I guess like when a user searches or filters, you want there to be low latency, so that way the user's like not like, I guess, I don't know, like turned away by the
Yeah.
by how long it's taking to search.
What would happen if it's too slow?
I I think they would just go to another platform, or maybe yeah, I think they would just go to another platform that's faster,
I mean,
like Google Maps.
it's a terrible user experience. But worst case is it crashes. Sometimes if some systems, if the API call takes too long, it hangs up. But
Oh, yeah.
latency here is more of do we really want somebody to go on Yelp and wait 10 minutes for it to show up? Is that reasonable these days?
No, it's definitely not.
Okay, so let's build it so our system has low latency. Can you, but also quantify it? What does it mean for something to be latency? What do you think?
Okay, yeah, sorry. There's like I remember there's like three terms and they're like all similar to like latency. There's like throughput, latency. Um, I guess
Yeah.
like latency in the from a user's perspective is how quickly they get the information they're requesting.
Hmm. Yeah. So what's a
Um,
reasonable time? Just throw out a random number.
I didn't. I think like under 5 seconds,
Yeah, I would say it's in the
probably.
milliseconds. Let's say 400 milliseconds low latency. Do you
Okay.
really want to wait? There's a certain latency that to the human eye, it's basically instant, and it's somewhere it's either 300, 400. There's a study on it, but
Oh.
essentially you don't want to say, oh, I want it in 5 milliseconds, but to the human eye, that's not that's not instant, or that's faster than a human could even perceive it. There's no point in making it
Mm,
that fast. You just
okay,
need to
that makes
make
sense.
it just needs to look instant to the user. So let's just say under 400 milliseconds. I forget what the exact number is. But if you go on Hello Interview, they'll tell you the exact milliseconds. Okay,
Okay, okay.
are you familiar with scalability? What scalability means?
Yeah, so I think it's like how much traffic your system can handle, either like users or like through like the amount of data it can process, or like that's how I think of scalability.
Yeah. So do we want our system to be scalable?
You definitely, yeah, we definitely want it to be scalable. Um, scalable. We definitely want it to be scalable. Why can't I type? And the reason, okay, sorry. We definitely want it to be scalable because like when we add when like when there's more restaurants appearing around the area, etc., we want to be able to like properly scale them, and so that way like uh, like we don't want to have to like do like giant data migrations from like database to database, something like that. And also like if there's more clients that are querying our website or our service, we definitely want them to um, we definitely want to be able to support like more users.
Yeah, exactly. We wanted to. So how would we support? Pretend pretend we have, and this is a regular scale. Right? Pretend we want to support 100 million active users or 400 million active users.
Okay.
So let's just say we want it to be scalable, and then we'll talk about how you're going to design that after. Um,
Uh oh yeah,
Go
sorry, go
ahead.
ahead. Oh, okay. So you want me to figure out like a way to like scale to 400 million active users? Is
Well,
that
we'll
kind of
see when you build your high level design, or you build the architecture. I'm gonna test you, or I'm gonna test it to make sure that it could support 400 million active users theoretically. But let's just say we want it to be scalable,
Mhm,
support 400 million active users,
mhm.
and then
Oh, okay.
and then are you familiar with availability and yeah.
Oh, yeah, yeah. So okay, yeah, I remember like the 5 nines um of availability, but yeah, like that's like the
What is
amount of
that?
wasn't it like the 99.999? It's like how how I don't know how to say how much like the percentage of time your
Okay.
system is up or guaranteed like to be up and running like basically just it basically doesn't crash or something like that.
Yeah. I mean, that one is, I guess that one's a bit less of an interesting concept because of course you'd want it to just be running as much as possible. But we'll
Yeah.
see when you design. But we'll talk about this. Of course we want it to be reliable, and there's multiple. I want to just make sure that your system is reliable.
Okay.
We want it to also be fault tolerant. Do you know what fault tolerant is?
Is that either like natural disasters or something happened and then like or like errors like user prone errors like can't um can't trigger that? Is that what it means? Like handle those
Yeah,
gracefully?
fault tolerant is, well, you're gonna be designing a system here. One thing would be there's no single point of failures and things like that. So this helps with reliability. That means like reliability, right? What does it mean to be reliable? That means it's always up. It's hopefully you could get to 100% uptime, right? But what does it mean
Mhm.
to be if something's up? You have a distributed or you have a system. Some things are gonna fail. If
Yeah.
one thing fails and it takes down your whole system, is it fault tolerant?
No, definitely
Yeah,
not.
yeah. And if it's not fault tolerant, if it just breaks, if one thing breaks, it's unreliable as well. So,
Mhm.
yeah, we'll talk about that. And then one thing would be, yeah, we would want it. I'll just say right now, we want it to be available. As in, it's kind of similar to reliability, but I'll just remove reliability right now. We'll just say we want it to be available. We want it so that whenever you go into your, like whenever we open up Yelp, we want to make sure that it's online, right? We don't want the case where it's being down. So
Mhm.
let's just say let's just look at it that lens. We want it so that when we open up our app, we always get some results, and we could
Okay.
always use it. We don't want to just show them a screen like we're down, come back in a few hours.
Yeah.
Okay, so now what? Now we have the functional, non-functional requirements.
Yeah, now I think we would probably go to like some sort of like high level design. Um, Also, like, sorry, this is like a general question of like
Sure.
just system design.
Mm-hmm.
These non-functional requirements kind of seem like generalizable to like a lot of different problems. Would you say that that's the case?
You'll often pick from the same set of six, seven, or eight non-functional requirements, but
Okay.
they'll differ. The non-functional requirements, depending on the problem that you're given, are going to be different. So, for example, um, for example, if I'm designing lead code, some of the non-functional requirements that we'll care about more is we'll care more about security because we're going to be somebody's going to be submitting code and it's going to be running on our servers. We don't want them. We don't want to be running code that's not good, right? So we want
Mm.
security is more important in that case, right?
Oh,
Um,
okay, I got you.
Designing Yelp versus designing something like Ticketmaster. Ticketmaster, people are competing for the same ticket. You don't want to double book. You give the same person the same ticket. So there's different non-functional requirements. So it depends on the problem, but I would say there's like a set of 10, less than 10, maybe even just 6 or 7
Mhm.
non-functional requirements that you would just pick out of those. But every problem is different.
Okay, that makes sense. That makes sense. Yeah. Okay. Yeah. Let me get into the high level design.
One thing that is one trade-off that you have to make in a lot of them is consistency versus availability.
Oh, is this a cap theorem?
Yeah, exactly.
Okay. Yeah.
So that's one thing. So depending on the problem, sometimes you prefer consistency, sometimes you prefer availability. Um, in cap theorem is versatility in a system with partitions. In a system that's partition intolerant or something.
Yeah.
But anyways, I'm telling you upfront that we want availability. So yeah, let's just move on to the high level design then.
Okay. Yeah. Okay. Let me see. Can I draw a shape here? Is that okay? Uh, let me draw a different shape. Um, okay. Okay. I guess like the first, like kind of high level. I want like I'm just gonna like we have our like client over here who's like requesting something, and this is like very general. This is still very general. Who's requesting something to our server, and then I was kind of thinking like we can later split up the different actions um, in the server, but for now I'm just gonna like try it out here. Who request some action, whether it's like filter, populate like the homepage, etc. And then lastly, we need kind of our we need our something to store everything, right? So and then this we can imagine as like partitioning like both ways, or not partitioning both ways, but this is querying both ways. So we have our like some sort of database here,
Yeah, this is the
and
DB.
yeah, yeah, uh, yeah. And so this is kind of like this is very generalized, right? And it's definitely not like it would accomplish like like some of the stuff, but then obviously we want like it to be available fault tolerant, and stuff like that. So kind of what I'm thinking here is we can start from the front, like the client perspective,
Mm,
and then we can kind of work our way back all the way to the database, like picking like our database and what sort of like how we want to store our data in that. So yeah, so starting from the client, so the client has kind of it seems like from our functional requirements, the client can do kind of essentially like one action. I want to say there's like a filter action, right? So there's initial load, restaurant load onto the feed, and then there's a client search. So we should have like some sort of like search, um, some sort of like search microservice, or
yeah.
a service that can handle like straight up just searching and filtering.
Mm. Also, one thing I'll say is let's just assume all of the business data is in the database now.
Okay.
We
Yeah,
don't
yeah,
have to
yeah.
worry
Okay,
about
that
that
makes
part.
it. Okay, cool. So yeah, we should have one sort of microservice for searching, and then uh, can I copy that? Yes, nice. And then one for like loading. Oh man, loading places onto home screen. So this is the initial render, and then so now our client can do one of two things. It can do it can search, it can filter, and yeah, it can filter, and this load thing will also happen simultaneously. And also these are all querying to this database. Um, I think from my perspective, these are the only two actions I need to account for. I'm saying that I'm assuming that like the search is, taking into account the proximity, the filtering, like all of that. I'm just gonna say is a part of search, and that can be on like one single node.
So we're
What are your
loading.
thoughts on?
So okay, can you just let's walk through a client interaction. Pretend a client requests a like a list of restaurants. I want
Mhm,
pretend the client requests a bunch of Mexican restaurants. Can you walk
mhm.
me through the flow here based on how you architected your system?
Yeah, so initially the client will load onto our Yelp clone, and then we will basically load them, like give them like a set of places, like almost like a feed on their homepage, and then they click the search, and then the search like Mexican restaurants, and that will filter by like name or like proximity or whatever else they wanted, and that should go by the top via the top flow, and then that will like instead of having like that initial feed, then it'll now be like a
Pretend
curated.
they don't have an initial feed. The first thing that they do is they just have a list and they could just search for let's trim down the scope where they just search for food category, right? So they just have a search bar and they or a drop down and they have a bunch of options. It's like Mexican, um, Chinese, etc. And then they
Uh-huh.
just choose one. So what happens there now? Could you explain it deeper? So what happens when they click search? Pretend they search that and then they click like some search button.
Okay. So I see. Is this like do you want me to talk about like the type of request and like what
Yeah,
that's doing,
exactly.
or
That's important. Yeah, I want to make sure. Yeah, what happens here when you this is the UI.
Mhm.
Yeah, could you just walk me through that? The server. This is the UI, and
Yeah.
they click the search button. What happens in your system now from the client and then to the server and etc.
Okay. Yeah. So this is definitely I'm thinking like some sort of like REST. This needs to be some sort of like REST API. Um and like specifically like a get here. I don't think we need like a WebSocket or something complicated. We're not writing to a database either since that's already populated.
Mm-hmm.
So this needs to be so we'll send that, and then we also need to send in the payload. We need to send like filter slash type of place. Um, yeah, so this needs to be in our payload, so that way we can on our database, pick like if we had SQL, for example, we could like do like a select and then by restaurant, select type restaurant or something like that. Um, yeah, I think this should be our like at least our API for search or filtering.
Mm-hmm.
Um,
So okay, they
yeah.
make that API call. What happens?
Mhm.
What do they pass into this API call?
This would be like the filter param. So like I guess from the drop down. So what am I thinking? From drop from the drop down, the set of choices, like the set. It could be either a set. Let's just say one of the choices. Like that should be what's passed in.
Can you be more
I'm trying to think.
specific? Something like this. You want to get REST API, right? So
Yeah.
how do you usually structure a get request? What would that look like? It would be
Oh,
yeah. Be more specific because right now it's like we have filter, we have a drop down. What's actually gonna? Could you just actually write out the path that we're gonna hit in the query parameters?
oh, I see. So it'd be I don't know if this is right. So it'd be like domain slash get. is it domain slash get or domain slash filter slash and then the payload? What's in uh, food type? Something like that.
Here, one way that I'll show this would be like usually you'll get the rest the you should look up like the format of how to do this, but it's usually like restaurant. Should spell that wrong. Restaurant, right? Should spell that wrong again. Whatever.
Yeah, restaurant's like a weirdly hard word to spell. I don't know why.
Make sure I spell that right. Oh, I messed up with that. Holy, spelled that. Okay, restaurant, right? So we have our
Yeah.
restaurant. We have our get restaurant. Restaurants,
Mhm.
right? And then, are you familiar with like query parameters? So at the end, you
Uh,
write query parameters.
is it? I know it's in the brackets, right?
Yeah, usually you can just be like food equals like um, food.
So like the dynamic stuff, right?
Yeah.
Uh,
So
oh, I
something like
see.
that.
Okay, so it's a question
And then
mark.
we could just
Okay,
be
okay.
like food equals the um, food type they selected. This, or you could even be like, this is an enum of Mexican, Chinese, right? This tells me clearly that you're making a get request to restaurants
Hmm.
and you're searching
Okay.
for the food.
Yeah, this
Okay,
makes sense.
now we send that get request and it hits the server. What happens?
Yeah, from a server's perspective, I think I mean, there should be, I mean, it needs to query like the database, right? So I guess this is where we talk about like if it's like a SQL versus no SQL database. Is that what you're getting at here, or is there like some like should I walk through like actual like script code on like
Or
what's
okay,
running on the server?
walk at a high level. What happens at the server when it gets this get request? Yeah, including hitting the database, but it needs to do other stuff too, right?
Yeah, yeah, I might here. I might be. Let me. Okay, so the get request hits the server.
Mm-hmm.
The server needs to log like it needs to first out separate like what like the payload needs to take out the payload.
Exactly.
Um, after that, it needs to at least connect to the database, and then it needs to use that payload param to find the specific like tables or like rows that have the query param in there, and then it needs to like aggregate that all um, to maybe like a list or something, and then return that into a JSON, like into some sort of JSON format, and then return that back to
Yeah.
the client.
Yeah, something like that. I would say first the server gets the get request or gets the request. Like you mentioned, it needs to extract the data out of the payload. So figuring out the food type that they search for. Then, in some cases, I mean, first off, in some cases, they need to authenticate. If it's not authenticated, or if it's good, usually you want to authenticate. Otherwise, you could just spam your server, or
Mhm.
or you're and if you want to hide other features, but essentially first authenticate if needed. Let's say in this case we don't need it. Take the data out of the payload and parse it. Then you should probably validate that that payload is what they say or is correct, because if it's not correct, then that's an issue. So pretend that it's not correct. What would we respond back to the user?
I'd probably respond with like some sort of like, oh, there might be some sort of like error code for this. I'm not really sure.
Yeah, are you familiar
Um,
with the different status codes?
I know. Okay, I know 300's reroute just from the tiny URL. 400 is like not found, so we could
Yeah.
return like a 404. Is that what we're saying here? Or like some
Or
sort of like
yeah.
400 something?
Well, there's different status code, and each one has signals to the client a different thing. So there's 404, 401s, 500s, right, 300s. So usually, so usually 400s is user error and 500 is server error.
Okay, okay.
But then
But
there's
in this
like
case,
different ones. Yeah, go ahead.
okay. Oh yeah, I was saying okay, so if we're using like if it's a choice between like 400 and 500, I feel like maybe this should be a 400 just because like it was the client that didn't
Yeah,
select the right
yeah,
place
exactly.
or
So yeah, we'd validate it for 400. So we'll just send 400 malformed request. Why do we send back status codes to the client?
uh I guess it's so they can debug on their end so that
Yeah.
they don't have to like yeah, they don't have to go into the server or anything.
Okay. Yeah. So basically, the we parse the get request, and then we validate it. We return
Hmm.
400 if it's malformed. If it's formed correctly, we use the payload in order to query the database.
Yeah.
Right. And when we query the database, we just return those results to the client. So that's what I would have expected you to say there. And you were close, but yeah, I'd have to look back on it. But
Yeah, that makes sense. That makes sense.
okay, let's just say we have this right. We're able to perform this get request and get the type of food.
Hmm.
Um, Now it's we're handling our functional requirements. Let's walk through the non-functional requirements. What would cause this to be low latency?
Um, definitely like we definitely won't be handling like a ton of traffic. So if there's like if there's a ton of traffic, all of a sudden our server will be overwhelmed, and then our queries won't be processed as quickly.
Yeah.
So definitely like scaling.
Okay.
And this is either like horizontal or vertical. I guess I prefer horizontal. Um, so we could just build out more. We can just build out more servers literally for this for
Yeah.
the search functionality.
Okay. Let's talk about the database quick. How are we going to be storing? Pretend we want to be able to search by food, and we want to be able to. Let's say this is what we want to return. Or yeah, how do we? Could you data model this a bit? Like do some data modeling. How are we going to store the restaurants in a database? This
Okay,
is an
yeah.
important part too.
Okay, I guess like the two things I'm kind of I mean, so it's like a choice between SQL and no SQL.
Or no, I'm talking about more specifically, how is the data table going to be structured? Like like what is the table going to look like? If you know what
Oh,
I mean.
okay. Yeah, so I guess it should be like
Like design the database schema.
mm, uh okay, this is where not gonna lie, I do have a little bit of trouble with this,
Mm-hmm.
but I guess like from what I understand of SQL, there needs to be some sort of like or I guess a table, there needs to be like the attributes of the place. So we need to store some sort of attributes, and then we need to also store the name. So I'm thinking like the name. We need to have like a name. We need to have a type of food. Maybe like a location. Um, there's no ratings. What else? Search proximity. So yeah, I think these are like the. I guess for the three filtering, we need to have name, type of food, like genre of food, and then like
Yeah. Okay.
location.
Let's think about. Okay. So let I would be more specific here. As similar to like the API, actually do it like this. So what is it? What would be the names of the actual columns
Um,
of the database, and what would be the name of the table?
I see. Okay, so I think these should be the names of the columns, like the three things I prototyped here.
Mm-hmm.
Those should be
Okay.
the column names,
Sure.
and then the name of the like table
Mm-hmm.
would just be like restaurants or something like that.
Sure. Okay. Okay. Um, what's the data type of each of these?
Oh, I see. Okay, yeah, this is so name is a string. Type of food should also be a string. Location, we could do like honestly, this should be like a. Could we do like a int like a tuple int of
Sure.
latitude and longitude, something like that.
You're writing
Okay.
something? Okay.
Oh yeah. Sorry. Yeah.
Okay. Um, okay. What about primary keys and foreign keys or any keys here?
Mm. Okay. Primary keys are what you filter on. Foreign keys are like what you use for like join statements, right, between tables. Um, do we do we need that? I guess like if somebody does like two things, then we would. No, I don't know if we need any of that.
Well,
Or I guess
every single table should have a primary key, right? What's a primary? Do you remember what a primary key in a database is?
that's what you like search on, right? That's like how you, I guess, index it, and um, yeah, I think that's how you like index it.
Well, yeah. Like, what are some properties of the primary key? Does it have to be unique across
Yeah,
all of
yeah, it
them?
definitely has to be unique.
Okay. So, which one would be our primary key? The name or no?
Um, no, I think we should have like another thing like ID, and then that's just like some sort of unique int. I think like
Okay.
with like fast food restaurants, yeah, you can have like multiple locations, and then
Okay.
it gets
And that's going to be the
complicated.
primary key, and the name is just a string. It's not a primary key.
Yeah.
Okay.
Oh, okay. Yeah, I don't know if you could see what I'm typing, but
Yeah, I see it now. Okay. So this is our setup. We have an ID, an int, a name. We don't really care about typing for location right now. I removed that constraint. We're just searching by type of food.
okay.
But okay, pretend I had a million restaurants on in my database and I performed a query on it by food.
Mhm.
So will that at all slow down? Will that at all scale? Pretend people just keep adding restaurants, adding restaurants, adding restaurants.
Yeah. So yeah, that definitely won't scale just because like yeah, it just won't scale.
Why?
Just because we will have like multiple types of restaurants, and if somebody's doing like filtering like one type of restaurant, it'd have to like go through the entire database and spit like pick out those specific ones. Um, I guess like one way to do it is like you could like shard, but like you could do that by like database type or not database type, sorry. Food type. So like you could have like Mexican restaurants, for example, in one database. So you can already pre-sort, and then you could like in the case that there's a complex query, like there's multiple food types, then you could do like a join of those tables.
Mm-hmm.
I don't know if that's
But
one valid.
if I search for, it just adds a bunch of complexity. I think because then we have like 6, 7 different servers, and all of them are only hosting. One's like server for Mexican food, one for Chinese food, and then
uh,
we can't leverage SQL features because they're not under the same database anymore. Like we can't
yeah,
just be like aggregate me all of the amount of uh like what the moment we need to search between two of them, like
yeah,
I think with only a million restaurants we could store it all in the same table. The storage is not a problem. I think the
okay,
main problem that I'm trying to figure out is, will our query be slow if this is how our database is structured, if how, this our data is modeled, because what happens when we search the database, if this is our only primary key, we pretty
hmm
much we pretty much have to do a full table scan on our
yeah.
database to find all the ones type of food. So we have to read in a million rows and then just pick the ones that are Mexican. What's a way to speed that up?
Um, like, are you talking about like restructuring the table, or like, is there like a way we can cache queries? Um, uh, yeah, because like, okay, we can't use food type as our primary key, so because it's not unique. God, yeah, the only thing I'm kind of leaning on is like caching like queries. If
Caching.
you query
Okay.
me,
Are
yeah.
you familiar with database indexing?
Not not that deeply.
Yeah.
No.
So one way to speed up the queries would be to introduce an index on like that on that column.
Sorry, can you say that one more time?
One way to increase to make the make queries more efficient is introducing the indexes to your tables. So what an index would do is it will essentially allow you to search faster in your database because it keeps the data stored in a sorted order. So it's similar to
Hmm.
like an appendix. So it
Okay.
basically builds, it requires more space because now you have this index. But how you could imagine the index is it's sort of like a reverse lookup.
Hmm.
So if you look at appendix in a book, so how that would look like is essentially what I know is it will store the food in order, but in a different data structure, and that allows you to
Okay.
find all of the food, all of the same food a lot faster.
Oh, I see. So it's like going on back to the Mexican like food. Would it be like my index from like 10 to 15, like that's all like Mexican places?
Yeah,
Is that kind of how?
it will essentially put all the Mexicans beside each other in some sort of data structure.
Oh, okay. I didn't think about that.
Yeah,
Okay, yeah, that makes sense.
like two, three. And now when you look for Mexican ones, they're all grouped together, and you don't have to do a full table scan.
Mm, yeah. Okay, that's cool. Okay, yeah,
Yeah.
I definitely need
So
to
when
read
you
up on
create a
that.
primary key, it's essentially making an index on your
Hmm.
ID. It's building an index there. And the reason it's building an index there is so that you don't break the primary key constraint of having multiple keys with the same value.
Okay, do you think I should have had like could I get rid of the primary key and then put it on the type of food, or is that not like you can't do that?
Well, the type of food is not unique. Primary key needs to be unique, so that's one other thing.
I see, but like we indexed it on primary key, you know what I mean? So how does that work?
Well,
We-
primary key that was just a small implementation detail that I mentioned
Okay,
that when you create a primary key, it essentially creates an index on it as well. And most of
okay,
the time the indexes are B trees when it comes to
okay.
Postgres or whatever. But
Mhm.
when you have a slow query, a lot of times you just need to figure out if I can introduce an index to make that query faster.
Okay, okay, that makes sense. Yeah,
Okay, let's
cool.
talk about one more part. Okay, now pretend we added index on the type of food and the queries
Hmm.
are happening really fast now.
Yeah.
Um, let's talk about now the database is not the slow part, but we just have way too many clients
Hmm.
using the one server. Now the server is being overloaded. What would be what would happen there?
Right. Yeah. So I guess this goes back to like the horizontal scaling. So you can horizontally scale, so you can have multiple server instances, and then I feel like I've seen this a lot, but a lot of people just say like just put a load balancer in front of those server instances, and so that way it could like route traffic to the server that's like not being used. Um, yeah, I guess like that would be one possible
Okay,
solution.
could you augment sort of your system here so that it has a load balancer? What would that look like?
Yeah, we have all of these. Some like this. Like, oh man. Yeah, so go to this load balancer. Oh, um, and then this load balancer can like route traffic to the different servers. And then those servers can query the database. Be so something like this.
Okay. So how is this going to improve the system?
I think. this makes it more reliable and scalable.
Why?
Uh, Reliable in the sense that now like we're not relying on like one single server to fulfill all our requests, and then scalable in the sense that we can like scale the server instances in proportion to our like client demand, so we can always like spin up more, and then the load balancer can always route to like the most available service or server node.
Okay. Yeah, makes sense. Okay, we're running at 50 minutes. How do you think you did? Like, what's your thoughts so far?
I definitely okay. So this is like something I need to get better at. I haven't done a lot of system design interviews, and I guess it kind of showed in like the onsite.
Mm-hmm.
Uh, but yeah, no, I definitely need to get better at this in general. I feel like I need not really like the high level. I need to get more nitty gritty. So like I think that kind of was clear in the request, like formatting the request that you mentioned, but also in the indexing too. Like I didn't know at all that you could like index. I mean, I feel like I did know, but like I didn't ever use like indexing on like a certain like attribute in the database.
Mm-hmm.
So I definitely could have. I definitely just need to like get more nitty gritty so I can explain it at like a still a high level, but like a fairly like technical high level, if that makes sense.
Mm-hmm. Okay. Yeah. I think you need to just follow us when you do these. Probably comes with more practice, but follow a specific order that works best for you. So the way I like to do it is talk about the functional requirements,
Hmm.
then non-functional. So I'll write this. The steps here. You'll see up here. Functional, non-functional, right? But it's been a while since I did this. Non-functional. Then I'll talk about the APIs. So what are the APIs that we're gonna hit, right?
Hmm.
Then I talk about the data models. So that's kind of what you're doing here is like, okay, we need a get request. Oh, and then we need a post request for them to add businesses, right? And then I talk about
Yeah.
the data models. Or I think it depends. Usually I talk about the data models first. So when I talk about data models, I'll just say, oh, so we're building Yelp. So what we need to do is have restaurants. Like we're gonna have a table for restaurants. We're gonna have a table for users, maybe businesses. So you see what I mean? So I list out the data model, then I list out the APIs, and a lot of times I list out the data models just briefly like this because we'll get deeper into it. Then I list out the
Okay.
APIs, and you should be very specific in how you list out the APIs. I want to get requests on restaurants. These are my food parameters, or these are my parameters. You need to talk about what's in the request, what's in the payload, right? If it's a post, you need to talk about how the server is going to respond. If it's going to respond 400, 401,
Hmm.
500, you need to talk about you need to actually talk about the response because those are two important parts. Is it the HTTP verb? The most important parts of the HTTP I would say is probably the verb that you're using, the verbs, the paths. So that's the path here. Right?
Uh-huh.
Query parameters. So that allows you to do different filtering. Payload. If you're doing a post request, you're gonna have a body that's have a payload, and then like response, and then some other nice to have is like authentication and stuff. But when you're talking about the APIs, you should list out every single API that you're gonna be using, and then all of these different things. Be very specific.
Okay. Yeah, the auth is that's like authorizing like checking whether the client requesting the thing is like actually like a real person and not like so they don't get overwhelmed with fake stuff. Is that what that means?
Yeah. So for example, I tell you to design Instagram newsfeed. How am I gonna
Hmm.
make it so that I see my feed and I can't see any other people's feed?
Oh, I see. Okay. So it's like some user ID or something like that.
So authentication, there's two buzzwords here or words you need to know. Authentication is you are who you say you are, auth, and authorization. So authentication means you are who you say you are. Authorization is how we limit you to exactly what you can see based on who you are. So there's two different steps to that.
Okay, that makes sense. Yeah.
Okay, so I think you just need to follow a good process. I think with the non-functional, you need to just study more on some of the distributed systems theory. So understanding latency and how that affects the user experience. What even is latency? What is
Hmm.
the cap theorem? Why do we have to make this trade-off of consistency or availability? What's what's fault tolerance? What's reliable? Like understand that theory because it will show in this section right here.
Yeah. Yeah, that makes sense. Yeah.
Yeah. Um, yeah, familiarize yourself with the APIs, get deeper in that, as in like the different verbs, how the path should be constructed, when you should use query parameters or when you should just pass things into the payload, when how the responses are the different responses that you're working on, and
Hmm.
then definitely like practice a bit more on the data modeling too, like be able to
Yeah.
model the restaurants table with a primary key. And you should be very specific too. Like I want an ID and it should be a UUID. I want a name and it should be a string. I want a um, like phone number and it should just be numbers. Like the format of what you're storing there, because that's important. Like
Yeah.
pretend I'm
Okay, that
telling
makes
you
sense.
to tell and pretend I'm telling you model a person in the database. You should be able to create. You'll be like, oh, I want to model. Like pretend I said, can you write me a data model for a bunch of users in our database? Right? So you need to be able to, yeah, be like, okay, I'm gonna have an ID for the user, and that's gonna be the primary key. Then I'm gonna have their name. Then I'm gonna have their age, which is gonna be a what's it called, an integer. You know what I mean,
Yeah. Okay,
you
that
need to
makes
be
sense.
very specific on those, and then you need to our database right here is very simple, but if there's multiple tables, you need to specify foreign keys and I mean the primary keys you always have to I'll always expect you to say a primary key, but if we have restaurants and maybe there's owners, right, and then the restaurant sort of relates to owners, I want you to tell me that there's going to be an owner field on the restaurant with a foreign key to the owner, if that's the relationship we build. So it needs to be very
Oh,
specific, and you need to get through this fast too. Like we only have an hour. Um,
yeah.
let's see.
Yeah.
Definitely understand database indexing and how to speed up databases. So understand how an index speeds up the database, or how an index could speed up queries. So understand like
Mhm.
full table scans and how it could be issues and how you can use an index to avoid having to scan the whole table.
Yeah. Yeah, that makes sense. Yeah.
Um, yeah, I think that would be a start. And then yeah, we should do this again some other time. You should message me. Let's do another system design soon. Study up on what I said here. I think
Yeah.
after that, you should be really good for the next one.
Yeah. Yeah. I noticed that like I'm also like kind of slow too. So I definitely need to start running through a bunch of examples so I can get a little faster at these problems.
You'll literally open up an Excalibur and just be like design Yelp and try this again by yourself tomorrow, or
Okay.
maybe later today, or take some time off. But just put design Yelp and then try to see where you get to within an hour. That's how I
Okay.
practice.
Okay.
But yeah,
Yeah, that's
cool.
fair.
All right, thanks for
Yeah.
coming out.
Yeah.
Hopefully that was
Thanks.
helpful.
No, that was super helpful. Thanks, man.
All right,
Appreciate it a
see ya.
lot. See
All
you.
right, bye.